Hello, and thank you for watching this screencast. Today, our lesson is going to be on factoring a specific type of trinomial. Recently, in our most previous lessons, we've been going through and talking about how to express a trinomial as a product of two binomials. And so today's kind of a special case with that. I know I've taught y'all about GCF and we've done difference of squares. This is actually what I like to call my third and final bread and butter factoring technique. I always check for this before I look to maybe do the magic method or another type of factoring technique. It's called Perfect Square Trinomial. You might notice over on the right hand side here, I've got my list in green of all of our perfect squares 1 through 20. And this is a good list for you to have memorized. I recommend definitely knowing 1 through 15, and then it's kind of helpful to know 16, 17, 18, 19, and I think everybody already knows 20. But being able to recognize your perfect squares is valuable. Now, what a perfect square trinomial is this obviously a three-term polynomial where the first term is a perfect square, the last term is a perfect square, and then the middle term is a combination of 2 times the square root of each of the first and last terms, respectively. And the way that it factors out, instead of a binomial times its conjugate like we've seen before with the difference of two squares, instead of some random binomial times another different binomial, it's actually going to be a binomial times itself. So in this case, a plus b times a plus b, or a minus b times a minus b in the second case you see down there. Now, I'd say in black here, these are just basic kind of templates. And what we're going to do is we're going to use these templates to kind of understand how to factor some specific examples. Like looking down here at the bottom of your screen, you'll notice I got our first specific example for today. And you don't have to go into great detail as far as this checklist, but sometimes I like to have with my students learning the perfect square trinomial factorization for the first time, I like to go through this checklist and I say, well, okay, is the first term a perfect square? And if it's a perfect square, that means that we can split it up into two identical factors. I'll go ahead and let the cat out of the bag that anything that's raised to an even exponent, fellas, is a perfect square. X to the second, x to the fourth, x to the sixth, x to the eighth, x to the 10th, yada, yada, yada. All of those are perfect squares. X to the 100th is a perfect square. You'd split it up as x to the 50 times x to the 50. So we can say definitely that x squared is a perfect square. So we move on. Is the last term of perfect squares 25 a perfect square? Well, we see it on our list up here. We know that it's 5 times 5. So we'd say, yep, second check. There we go. Now this third and final check is of the utmost importance because it says, is the middle term a combination of 2 times the square root of each of these first and last terms? So in other words, what's 2 times x times 5? If that's that middle term, 10x, then we are in business. And what we do is we just fill in the template. And I like to use the sign. You might have noticed, in fact, that I just circled x, a plus, and a 5. That's going to be what we fill in our template with, x plus and 5. And then remembering that it's a binomial squared, that's exactly what we're going to do. We're going to write it as x plus 5 quantity squared. Okay? Here's our next example. 9x squared, 12x, and 4. Like some students might look at this and say, oh, that's magic method, Coach Morgan. I'm going to use magic method because I see, that leading coefficient is other than 1. Man, you'd have a lot of work to do if you thought this was a magic method problem because bread and butter factoring technique, it tells us, hey, check first to see, is this a perfect square trinomial? And let's see. 9x squared could be split up as 3x times 3x. 4 could be split up as 2 times 2. And so when we circle, we think, all right, well, what's 2 times 3x times 2? In other words, double, or I take twice the product of those two square roots. Well, 2 times 3x times 2 winds up being 12x. So that indeed works out to be a PST. It's going to factor accordingly. And the template filled in is going to be 3x plus 2 quantity squared. Okay, it's just that simple. Some students might look at it and say, well, maybe I can write it as 3x plus 2 times 3x plus 2. Now, technically that is correct, but as far as convention goes, we want to use that exponent. We would prefer this as opposed to that because later on there's going to be some contexts when we're doing things like completing the square and using the square root method to solve quadratic equations. We're going to want to be in the habit of expressing it with an exponent. If you look at example 3 here, we've got 81x squared minus 72x plus 16. And go ahead and pause the video now. You guys that are watching this in class or watching this at home, pause your video, work this one out on your own. Work out example 3 on your own. Check to see if it's a PST. And if so, see if you can factor it accordingly. And then just a second, we'll pick up with the answer. All right. So having had a minute, hopefully, to work this out, let's see how you guys did. We split up the first term. Is it a perfect square? Absolutely. It's 9x times 9x. The last term, is it a perfect square? Sure it is. 4 times 4. Now I'm going to circle. I'm going to check what's 9x times 4. All right, so that's 36x. And if I double that, I get what's in the middle. That's 72x. So I'm going to use that sign in the middle, and I'll say, all right, my answer is going to be 9x minus 4 quantity squared. Now, I'd venture guess one of the common mistakes is maybe forgetting to put the minus sign in the middle there, and just check your answer by foiling, and it should be obvious that we wanted that negative 4 in there so that we get a negative 72. Okay, now we've done 3 examples. They're all 3 basic, what I'd consider A-level examples. Now let's ratchet up the difficulty a little bit, and let's take a look at what I might call a curve ball here. Okay, now in this case, we've got 36x to the 4th, 84x squared y, and 49y squared. First thing that I notice here is that there's a couple variables. So if I were you, I've given you this suggestion before, but I would just simply ignore that second variable. Okay, pretend like it ain't even there. And consider, what would I do now? Is this a perfect square? Well, 36x to the 4th, it is. But let me ask you, how would you split that up? Sure, go ahead. Think about it. How would you split that up? Well, we know 36 is 6 times 6, but x to the 4th is going to need me to say x squared. So I've got 6x squared and 6x squared. Did you put that? I hope so. If so, good for you, man. If not, make that correction in your notes. We're going to split 49 up, okay? We'll split 49 up as 7 times 7. And then we get this notion of, okay, 6x squared and 7, that's 42x squared. And they're doubling that, we'd get 84x squared. So this is a PST, and we like our results. Now that we kind of figured how this would work, I'm going to go through and very carefully, there we go, trying to erase what I marked out earlier, because now we can say, you know what, it's going to be, instead of 7, it's going to be 7y. And that would get the job done for us here. So we got 6x squared. We temporarily ignored that second variable if needs be. You guys can do that. You might not have to. But anyway, we'll fill in and out our template. We got 6x squared plus 7y quantity squared. You can go through and FOIL it out. You can check your answer by foiling that. So that curveball right there is where we introduce a couple of variables. Why don't you guys try example 5 here? Okay, so go ahead and pause the video again, give it a shot. You got a couple of variables. You can temporarily ignore it, or if you want to, you can handle them both, the A and the B, all there at once. I'll give you a couple moments, and then when you're ready, you can push play and see how you did. All right, hopefully you guys had a chance to wrap this example up. Let's see how you guys did. Is 100a squared a perfect square? Yes, it is. So what would we say? 10a times 10a. Check yourself. Hopefully we got that. 9b squared, that's 3b and 3b. Once again, good for you if that's what you got. Now I'm going to circle both of these, and I got 10a times 3b. Now here's a little trick though. Okay, I might have been a little, maybe a little mean on this one, but this is not a PST. This is not a perfect square trinomial, because although that middle term is 10a times 3b, we're supposed to have twice that. What would that middle term need to be in order for this to be a perfect square trinomial? It would need to be negative 60ab. As it is, this one is a DNF. Did you catch that trick? I hope you did. This one's a does not factor. Okay, it's not a perfect square trinomial because there's that middle term was not what it was supposed to be. And you know what? I would venture a guess that some of y'all probably said 10a minus 3b quantity squared. And if that's the case, let me challenge you real quick. FOIL that out and see what you get. What's 10a minus 3b times 10a minus 3b? All right, if we do our first times first, yeah, well, no, we get 100a squared, and that's looking nice. If we did our last times our last, yeah, we'd get plus 9b squared. So far, so good, Coach Morgan. I got my first one, I got my last one. But look at what happens when we get the outer and the inner. When I do my outer two, right, I get, negative 30ab. And when I do my inner 2, I get another negative 30ab. So if we were going to put this whole thing together, it would need to be negative 60ab for that middle term in order for this to be factorable as a PST. And as we mentioned a moment ago, that's not what it was. And therefore, this one's a DNF. It does not factor. So I hope you have gotten some good work done here on these perfect square trinomials. Again, this is one of our bread and butter factoring techniques that we always want to check for first before we jump into some more complicated methods. If you have any questions, you let me know via email. I will see you guys in class on Friday. And then don't forget you've got your homework assignment through Delta Math that is due Friday at 3 p.m. So thanks again and have a wonderful day.